Okay, so this is part two of the final review, and hopefully we'll get through all the rest of the questions. We'll see. If we do, that would be awesome. And okay, so pay-per-view, and in the first video, I did questions 1 through 19. So I'm going to start here on question 20. I don't have to worry about whether or not any of these match anything because there's no matching. And so, okay. So I have absolute value inequality here, and so how you solve absolute value inequality? I mean, we're talking, friends. It is really it's and go back and look in your notes. We have the if then statements, and so I'll be writing down the if then statements. So right here, you have to have absolute value all by itself. So I'm going to take away 4, and when I do, I get 2a plus 1 absolute value, I'll make that big and dark, is greater than 3. And with absolute value, it really matters if you have positive, negative, or 0. That's what really matters. And so if you go and you look up this statement, and I'm going to put a star here, and I know that in the notes I didn't have a star there, but that's how I don't remember what we had. I think they had a capital X is what I think they used from your book. So I'm just using a star. It doesn't matter what it is. In this case, it's 2a plus 1. And if that is greater than a positive number, which 3, we have 3 again. And this is the if, and then this is the then. Then star is less than or equal to, in this case, because it's or equal to, the negative of that positive number, or, and you got to find all of the solutions. And so I know people want to say, and these are the solutions, but it's this is solutions or these are solutions. I have, oh, it is star. I thought I thought it was X there, but it is star. It's whatever you have on the inside. And the star is greater than or equal to the positive of that number. Okay, so this is the if-then statement that I would have on my note sheet that I would be going and looking at for absolute value. And I wrote all of them on the board with star, but I know in the notes I think they use capital X. Okay, and so that's what I have here, right? This is I'm matching the one I have. There's going to be one that if I have less than or equal to, and there's going to be a positive number, and there's going to be ones that are greater than a negative number, and there's 0. So, okay. So my star is 2a plus 1. So this means I have to solve 2a plus 1 is less than negative 3. And then my other solutions, or 2a plus 1 is greater than 3. And I'm going to take away 1. So I get 2a is less than or equal to negative 4. And then I'm going to divide by 2. So I get a is less than or equal to negative 2. And taking away 1 here. And I wish I would have had more room here. 2a, I always write so big. You know how that goes. Greater than, you're like, yeah, me too. Divide by 2. But now I will have somewhere to tell myself, hey, you need more room. So I'm going to put this on the number line just so that we can see what we have, so that I can write it in interval notation. And I'm going to write that down here because I'm a little out of room. So I have negative 2, I have closed circle, and I have less than, so it's that way. And I have 1, and I have closed circle, and I have greater than, so it's that way. So these solutions are going from negative infinity to negative 2, and you use the bracket because it was closed circle, and then union 1 to infinity, and always parentheses with infinity. I'm not going to actually run out of room like that, like I did on this other one, because when you take away 4, you get negative. 2a plus 1 is greater than negative 1. And your book, the author of the book, XYZ Publishing people, said, hey, you can reason that out. And they're certainly right. You can reason that out. No matter what you have in here, call it star. If that is an absolute value, right? Absolute value of star is a positive value. Will that always be greater than or equal to? greater than, right? It only meets one of the conditions, and it's going to meet the condition of being greater than -1. And the answer is that's true for every value. And so we could have had this if, and I did put these on the board, absolute value of star is greater than or equal to a negative number, then the answer is all real numbers is your answer, which you can write all real numbers on the solution line, or you can write negative infinity to positive infinity, your choice on that. So I'm going to write all real numbers. And so it is this is my if then. I wrote all the if thens on the board, and I'm sure that you have it in your notes, and that's what I would put on my note sheet, because when you take your final exam, I might have this one or I might have one of the others, right? And so you want to make sure that you have them all. I remember I wrote them on the sideboard is where I wrote them, and a lot of people took a picture. So you might have taken a picture. Okay. And then it says for me to graph the following, state the domain and the range and whether it's a function. And remember that the important things to say on circles is the center and the radius. On ellipses is the A and the B. On hyperbolas, A and B. Parabolas, the vertex are important features. So I'm looking at it. I'm supposed to identify the shape. I have x to the first and I have y to the second. And so if it's quadratic in one variable and linear in the other, it's a parabola. So I'm like, ooh, it's a parabola. Ooh, how did I go back to person view? Paper view, person view, paper view. Oh, I don't know. I clicked on it and it changed views. That wasn't what I was wanting. Okay, parabola. This parabola is actually in vertex form. And so I don't know if you guys remember the vertex form for ones on its side was x equals y minus h quantity squared plus k, where that's going to be the y coordinate of the vertex. I'm not even sure if we did that in the class. I'm feeling like we did not. We only did it for y equals. Excuse me, and don't look at that. Remember, what you want to pick in order to find the vertex is you want to pick the value that makes the base be 0. And that was the same in vertex form. So we want to pick y is 3, because that would make this be, and this is going to be our vertex. Y is 3. Makes the base be 0. My son is very sick. He is staying with me in Baco until I done working. Sorry. And I would pause the video, but I don't know how to do that. Okay, so we have x equals 3 minus 3 squared plus 1. I'm putting in y as 3. That's 0 squared, so I get x equals 1. So that's the vertex. And I'm going to put that on here. So over 1 up 3. I did this problem in class. I don't remember which class I did it in. And I plotted 3, 1 instead of 1, 3. And it was not coming out. And I'm like, what have I done wrong? And so remember, this one's in terms of y instead of in terms of x. We're more used to in terms of x because we've practiced that a lot more. These ones that were in terms of y actually were in, I don't remember what unit was, unit 3. And the ones that were in terms of x were in unit 5. So we've done them more recently, of course. And that's my goddaughter. She needs to kill an hour. Are you still on campus? And yes, usually I would still be on campus, but not today because I had to come home and make this video. So I want to pick things that are close to 3. Y is 3. So that's my vertex. So I'm going to pick 1 below and 1 above. So that would be 2 and 4. And then those should be equal to one another because of symmetry. So when I put that in my calculator to find out what x is, so parentheses, and we're going to put right in here 2 minus 3 quantity squared plus 1. And so, and this is going to be what x is. So x is 2. And then I'm going to go and edit the 2, and I'm going to put in 4. And because they're the same distance from the vertex, they should be equal to one another, and they are. They're both 2. And then now, remember the vertex was 3, so I did 1 below and 1 above. Now I'm going to do 2 above and 2 below. So 2 below would be 1, and 2 above would be 5. And I wish I wouldn't have accidentally cleared that out with my, I don't know how I cleared that out, but I did. That sometimes happens. So I'm putting in 1 minus 3, having to type it in, and I could have just edited, and that would have been lovely. And I'm getting 5. And I should, when I put in 5 here, I should also get 5, so you can check that that's true. And then I'm going to plot these. So over 2 up 2, over 2 up 4, over 5, so that's 2, 3, 4, 5 up 1, and up 5. And so I see that I have a parabola that is laying on its side. Of course, I expected it to be on its side because it was x equals. And so here, and I know that we have not drawn one of these on its side like this since chapter Unit 3. And you're like, oh, that was a long time ago. In Unit 3, they also asked you things like, what is the domain? And the domain are the x's. And my x's are how far it goes left and right. And where it starts is right here at 1. And so the start for the domain is at 1. And I use a block, because the bracket, because it shows it starts at 1. And then where does it end? Well, it just goes on forever. So it ends at infinity, 1 to infinity. And then the range is, well, how high does it go? And it might not look like it, but this parabola, as it's going upward, just goes slowly up and up and up and up. So it goes all the way to the top. And how low does it go? Well, it goes all the way to the bottom, and you always go small to large. So it starts at negative infinity. That's all the way down to the very bottom. It keeps going lower and lower and lower and lower, negative infinity to positive infinity. And then they ask us, is this a function? And you remember that if a vertical line, a straight up and down line, hits your graph twice, it's not a function. So this is, nope, it's not a function. And then this one is asking us to sketch the graph. And we've done these more recently because this one's y equals. And because it's x squared, so we have y to the first and x to the second. We know that it's a parabola as well. So the important feature that we want to have is the vertex. So I'm going to put the vertex right here. That's the important feature on a parabola. It's not good enough to say that the important feature is the vertex. You need to say the ordered pair of the vertex. So how you find the vertex is x equals, I'm just listening to him cough. And I already said he was really sick, right? And so anyway, so we have negative 12 over 2 times 3, which is negative 2 when the dust clears. So right here, my x-coordinate of my vertex is at negative 2. How you find the y-coordinate is you just plug in. So y equals, and this is going to be 3 times what squared plus 12 times the what plus 5. And I'm going to be putting in negative 2. And I'm going to save this because when I go to find more points, remember on a parabola, I like to have 5 points. I'm just going to use this to find those points. So I have 3, and then I have negative 2 squared plus 12 times negative 2 plus 5, and I get negative 7. So 2, negative 7, but the A is positive, so it's opening upward. So it's going to be on my graph. So that's good. So I'm going to pick some convenient points right here. That's what these were called as well. Convenient points, just kind of easy. I'm picking them close to the vertex. This one's in terms of x. So I'm going to pick, I'm right here at negative 2, negative 7. There's my vertex. and I want to pick -1 and -3, -1 and -3, and they should be symmetric. And I want to also pick 0 and -4. And they should be symmetric. So I'm going to come in here and I'm going to edit out the -2 for -1. I got to do it in two places. Do I have that's showing, kind of almost showing, a little bit glary. And I get -4. When I go and edit the -1s to be -3, I should get -4 as well. I like to check that. And so there's days when I'm like so tired that I'm like, because of symmetry, it's going to be the same. And there's other days that I think I better put that in. And I just put it in wrong. I put in -4 on accident and got 5. So I was like shocked because I was like not getting the same. I was trying to put in -3, but got talking and for whatever reason didn't put in -3, which should have been the same, which was -4. And now when I put in 0, I should also get 5 because they're, and so I'm kind of putting them all in and letting my arithmetic verify the symmetry that I knew that I was going to have. So let's see, -1, -4, 1, 2, 3, 4, and -3, -4, and 0, 5. Boy, this is a skinny parabola. Yeah, because of the A is 3. 1, 2, 3, 4, 5, and -4, and up 5. And so I was gonna say this parabola it's beautiful. Okay, and they didn't ask me about the domain and the range and whether or not it was a function. They could have asked me all of those questions, but this question came from Unit 5, and they had us graph parabolas in Unit 3 and Unit 5, and in Unit 3 they asked these questions along with it, and they graphed ones that were like this, right side up, and ones that were on its side. And in Unit 5 we only graphed ones that were right side up and upside down, and didn't ask about the domain and the range. And so I'm not going to answer anything they don't ask because, I've already done enough. And are you going to focus, my friend? Okay. And so sketch the graph. So I have to figure out first what it is. So I notice that it's quadratic in x and quadratic in y. And the coefficient of x is 1. So this is what I'm thinking in my little head. The coefficient of x squared is 1. And the coefficient of y squared is -4. And because they're different signs, I know that it's a hyperbola. If they're equal to one another, it's a circle. And if they're different, if they're the same, they're not equal to one another but the same sign, it's an ellipse. And if they're not the same sign, it's a hyperbola. So, and the important features on a hyperbola is A and B. In order to find A and B, so here's a hyperbola, you have to get it in standard form, which means you need 1 on one side of the equation. And right now, 1 on one side of the equation. And right now we have 36, but we want 1. So we need to divide by 36. So we've done this, and we've used the number 36 a number of times. You're probably saying x squared over 36 minus, now 4 divided by 36 is 9 in the denominator. Y squared over 9 equals 1. So now I know that a squared equals 36. So a equals 6. And b squared equals 9. And so b equals 3. And so that means that from the center, and all of our hyperbolas are centered at 0, 0. When you go to Math 1, you'll find some that are not centered at 0, 0. And this will tell you from the center, go 6 to the left and 6 to the right. Go up 3 and down 3 from the center. But our center is 0, 0. So people ask me, why don't you just say that it crosses at 6 and -6? And I just plotted 5, sorry. And the reason is because it only does that when it's centered at the origin. So I like to say from the center, this way 6 and that way 6. So it's the same language that you will be using when you get to Math 1. All the dogs in the neighborhood are barking. At what? I don't know. I'm not going to go out and ask them. Why are you barking? And so I'm drawing my box for my hyperbola. And you have the choice of using the box method for graphing, making the asymptotes of the hyperbola, or using the equation method. And in the box method, you use the corners of the box through the center to draw in the asymptotes, and asymptotes should be dotted. And you should use a ruler. And so here I have a beautiful ruler that I'm going to be using. I'm drawing my dotted line. The box method is kind of like a first time drawing hyperbolas kind of method, and finding the equation of the asymptotes is kind of like a second time doing hyperbolas kind of method. So you'll probably see that in Math 1. At least when I teach Math 1, that's what I do. And so now, because x squared was the positive one and y squared was the negative one, particularly, I guess we really need to make sure when we have it in standard form that that's the case. So when we have in standard form x squared is the positive one, that means it's crossing the x-axis. And so remember that this is the vertex. His cough sounds so painful. I hate listening to that bad cough. Makes me, I don't know what I could do to fix it. I wish I could. Okay, time fixes these kind of things. X squared plus y squared plus 8x minus 2y minus 15 equals 0. And so I'm noticing x squared and y squared, which tells me that it's in a circle, an ellipse, or a hyperbola. And because the coefficient of x squared is 1, x squared is 1, and the coefficient of y squared is 1, and they're equal to one another, I know that it is a circle. So I have to get it in the standard form of a circle. So just like hyperbola had a standard form, circles have a standard form. Their standard form looks like this: x minus h squared plus y minus k squared equals, and then the radius squared on the other side. How you get them in that form is you have to complete the square. So you get the x squared and plus 8x, and then you leave a little room for the c. And then plus y squared, and then minus 2y, and then you leave a little room for the c. And then you add 15 to the other side. And how you find the c, the new c, it equals b squared divided by, that's not right, sorry, b divided by 2 quantity squared. That's how you find the new c. Okay, and I'm going to have to do that twice. And I've written so big that it's not going to fit very nicely. So, but here, b is 8, divided by 2 is 4, squared is 16. So plus 16 right here and plus 16 right over here. And then minus 2 divided by 2 is negative 1. The negative 1 squared is positive 1. And then you want to factor this. And how that factors is x plus 4 times x plus 4, which is x plus 4 quantity squared, plus, and then how this factors is y minus 1 times y minus 1, which is y minus 1 quantity squared, and then equals, and 15 and 16 and 1 is 32. And you could use your calculator. So I have a center of my circle. Remember, it's the opposite, so it would be negative 4 and 1. And I have a radius squared, which is 32, which means my radius equals the square root of 32. And it's positive. I don't have to do the plus or minus. So square root of 32, I hate that coughing, radius equals 4 square roots of 2. I don't know if you can hear the coughing, but it makes my heart hurt. And 5.7. Hope I don't get sick too, though. And so I don't want to make anyone sick myself. 1, 2, 3, 4, and up 1. And so I'm going to go in every direction 5.7. So in this direction, 1, 2, 3, 4, 5.7. And it up 5.7. 1, 2, 3, 4, 5.7. Down 5.7. 1, 2, 3, 4, 5, 6, 7. Oops, I counted too many. I counted 7, not 5.7. I'm sorry, I was going to sleep. 1, 2, 3, 4, 5.7. And I've decided to use, do I have a piece of paper here? So I have an envelope, and I'm going to mark right here. And I'm going to use that to come over here. And then I'm going to use that to get a couple more points. And do you have to do this? And the answer is no, but I'm a professional. Of course, it's a funny joke that just making a few more points will make my circle a little bit nicer. Oh man, that's a beautiful circle. Okay. There's someone in the class that has a circle drawer, and their circles are beautiful. It says, find the equation of the line that passes through the points -3, 1, and 2, 7. So in order to find the equation of the line, I have to know what kind of line is it. And I have 4 types. Well, actually I have 3 types. Vertical, horizontal, and slanted. But there's 2 types of slanted. So I'm trying to figure out what it is. So I'm going to find the slope using the slope formula. That will tell me the type of line it is, because I know vertical lines have slope undefined. Horizontal lines have slope 0, and any numbered slope other than 0 is slanted. So this is 7 take away 1 divided by 2 take away -3. So this is 6 over 5. And so I know it's slanted. And I wish that I knew the y-intercept, but I don't know. If I plot this point, it's not on the y-axis. You can plot it up here, -3, 1. That's not on the y-axis. And 2, 7 over 2 up 7. That's not on the y-axis. So I'm going to have to use it's called point slope formula for building the line, since I don't know the y-intercept, and that's this formula, y minus y1 equals m times x minus x1. And so remember, equations of the line have y in them. So y, and then minus y1, which is 1, slope, which is 6 over 5, and then x, and then minus 3 for the x1. And I'm going to resolve that double negative. Remember, how you solve this for the equation is you resolve the double negative. So I did it. And then you distribute the slope. It's really cookbook, because you do the same thing every time. So distribute the slope. And so this is 6 over 5x. And then you can use your calculator to do 6 over 5 times 3. A positive times a positive is a positive. And then 6 over 5 times 3 is 18 over 5. And you can use your calculator. Y minus 1. And then the last step is always to add or subtract y1. In this case, it's going to be add y1. And so I get y equals 6 over 5, and I'm just writing as big as I want because I have plenty of paper down here. And I'm writing quite large, actually. So this is 18 over 5 plus 1, which is 23 over 5. So right here, that's my equation of my line in all its glory. And I'm like, hot diggity dog. Okay, that's 25. Will I make it to 35? I don't know. We'll see. Tired. I'm cold. I'm hungry. I'm not really hungry. Okay. It says find the equation of a vertical line that passes through the points negative 1, 3. So the equation of a vertical line is x equals a number. And you just got to go figure out what that number is. That's an M for number. And so you just go right here. There's the x is negative 3. X equals negative 3 is the equation of the vertical line. So it told us what x was. For the horizontal line, the equation, because that's what it's asking next, is y equals a number. So in this case, the number for y is 1. And so the equation is y equals 1. And so the horizontal line and the vertical line are very easy, but it's just a matter of knowing what to do. And then the slanted line, it says that it passes through the point negative 3, 1 and has slope 2. And the formula for the slanted line, if you don't know the y-intercept, which this is not the y-intercept, is y minus y1 equals m times x minus x1. There's the equation builder. Much more work, right? So this is for my slanted line. And this is my x1, y1. Can you still see that? You can. I haven't gotten off there. And this is my slope, so that's my m. So this is y minus 1 equals slope, which is 2, and then x minus 3. And then same story that we had before, resolve the double negative. So this is y minus 1 equals 2 times x plus 3. Then distribute the slope. So this is y minus 1 equals to x plus 6. And then add or subtract the y1, which in this case it's add. So add 1. This one was a little bit nicer than the last one we had because no fraction. So y equals 2x plus 7. Okay, so we did a lovely job on number 26. Number 27 says, use the graphing method to find the solution of the system. And so I'm certainly going to graph it first, and just like they asked me to do, but sometimes I get lazy and I use substitution. No, I'm going to get lazy and use substitution. I can't help myself. And then I'm going to graph both. So this is what I would actually do. I mean, I know that's not how I started off because we did not know the substitution method. But now that I know the substitution method, I'm like, well, look, this is set up to use substitution. So I'm going to plug that in right there. So this would be writing this equation down, 2x plus 3 times y, which is 2x minus 3, equals negative 1. So solving this is 2x plus 6x, so distributing here, 6x minus 9 equals negative 1. If this is too slow, the video, I should have said this at the beginning, and maybe I'll send out an email saying this. If I go too slow, put it on 2.5 speed. And you can do that on YouTube. It's pretty nice. And if I go too quick, put it on 0.75 speed. And also pause the video to catch up. And so it's hard to, when you're talking to stuffed animals, like this guy right here, he doesn't say much. And so he doesn't say, hey, slow down. Let me catch up. Let me combine like terms. And so, but I was just solving them quick so that you could see the answers. And of course, if I wasn't explaining anything, it would even go quicker. And so I'm going to add 9. And so I combined like terms and I added 9 kind of at the same time, and I'm getting 8. So I get 8x equals 8 and I get x equals 1. And I'm like, okay, the x coordinate of the solution is at 1. How I find the y coordinate of the solution is I just plug in. So this is y equals 2x minus 3, and I'm going to be putting in 1. So y equals 2 times 1 minus 3. So I get y equals negative 1. And so right here, 1, negative 1 is where the two lines are going to intersect one another. And now I'm going to graph both lines. So I'm going to put my my solutions for graphing over here because I made made my mess here. So this is y equals 2x minus 3. So I already know one solution, and that one solution is 1, negative 1. And and you can check and make sure that that is still a good solution by putting it in. That's probably a good idea. 2 times negative 1. Um, no, I'm supposed to put in 1 because x is 1. 2 times 1 minus 3. And I want to make sure that equals negative 1, and it did. Great. And then I'm going to pick another value. Let's say I choose 2. Then that would be 4. Take away 1. Take away 3 is 1. So 2, 1. So over 2, 1. And now I have 2 points on this line. And then I have to graph the other line, which was 2x plus 3y equals negative 1. So I'm going to go and graph that line. Now I know that 1, negative 1 was the solution, so it should be on the line. And I'm going to make sure that it is on the line. So when I put in 1 for x and I put in negative 1 for y, I get negative 1, and sure enough. And then I think if I put in 0, I get nasty numbers. It doesn't come out nice. And I want to pick another point, and I'd like the other point to not be terrible. And so I'm thinking about picking x's 2 because that makes 4. And and if I take away 3, I want that to be negative 4. And then I want this to be 3 so that I get negative 1. So that'll be 1. So negative 2, 1. So check that one works. That point works. So I did a little trickiness, right, on trying to make a nice point by saying to myself that 4 take away 3 would make 1, and I need it to be negative 4. So I put in 2 times negative 2. That makes negative 4 plus 3 times 1 is negative 1, sure enough. So I plot this point, 1, negative 1, and then the point negative 2, up 1. And I'm going to draw a line through them, and there I graphed both of them, right? And so that would be perfect if that's what you did, because when I ask you to use the graphing method, that means that you have to graph this line and you have to graph that line. And what I did was, and it didn't say I couldn't do this, but it didn't suggest doing it, as I found where they were going to intersect. I found this point using the substitution method, and then I graphed both lines. And so I thought that was quite clever. Unit 5. So it says, given the sequence, find S20. And so anytime that they ask me to find the sum of it, I want to know, is it arithmetic or is it geometric or neither? And so I'm looking at this and I'm thinking, if I multiply by 3, I get the next one. So that means it's geometric. And my R is 3. And so the formula for S20, the formula for Sn is equal to A1 and then r raised to the n minus 1 divided by r minus 1. Is that right? I think it is, right? I hope that's right, because I'm I don't have my formula sheet right here, and apparently don't have my thinking cap on. So this would make S20, I think it is, right, is 2, and then I have 3 raised to the 20 minus 1 divided by, what was my, 3 minus 1. So I'm going to put that in my calculator. And so I have I only put in parentheses around r if r is a negative number or if it is a fraction, just because it saves me a little bit of time not to. And wow, that's a big number. But you would think it would be a next big number, because the next number here is going to be, if you times it by 3, is going to be more than 160. And then the next, and times it by 3, and that's going to be more than 400. And then times it by 3, and that's going to be more than 1200. And you're going to do that so that you have 20 terms, right? And so this is a big number, but I kind of expected it to be a big number. Okay. And making sure that I wrote down the number right and didn't forget any digits. And now I kind of feel like, remember when I said I didn't really remember the formula? Well, you have the formula written down on your note sheet, so you wouldn't have to do this, but I feel like the need to verify that I'm okay. So I'm going to just come up here because then I'll have to make this video again. And so I'd have to look it up on my phone. And I have 4 terms here. So I'm going to try to find S4, which is the first term, which is 2, and then 3 raised to the 4 minus 1, divided by, and it's R, which is 3 minus 1. And so I'm going to change, the only thing in this is that to a 4. And the reason I'm doing that is because I can find S4, and then I can just kind of verify. So that's 80, right? I'm not going to put that on my answer line because nobody asked me about this. Why am I doing this? Because I couldn't remember the formula. And I said, I think this is the formula. I might be wrong. And so, and I'm going to compare that with 2 plus 6 plus 18 plus 54, adding up the first 4 terms, right? And if I get 80, then I'm going to be like, okay, good, good, good. And I did. I got 80. And so that makes me feel, and like I would now erase this because I don't want my teacher to think, why was I doing that? But the reason I was doing that was to verify my formula because I didn't have it right here, right? And you're like, you didn't erase that good enough. And you're right, I did not. Okay, now it's gone. Okay, determine the general term. Okay, so this is, when anyone asks me for the general term, I ask myself, is it arithmetic or is it geometric? And it looks like it's add 3. And certainly it is. It's add 3. So it's arithmetic, and the D is 3. So the formula for the general term is this, and should have n in it. And so a sub n equals a sub 1, which is 5, plus d, which is 3, times n minus 1. And you should always distribute and simplify. So this would be 5 plus 3n minus 3, and 5 take away 3 is 2. So this would be 3n plus 2. And then you could verify that this formula works. When I put in 1, I should get 5 because that's the first term. And I do. When I put in 2, I should get 8, which is the second term. 3 times 2 is 8 plus 2 is 8. Yes. And 3 times 2 is 6 plus 2 is 8. I said that wrong. 3, when I put in 3, I should get the third term. That's 9 plus 2 is 11. When I put in 4, I should get the fourth term, which is 12 plus 2 is 14. And so, and I like to check my workout. And then here it says to solve. And I'm like, oh, a linear equation. I just need to distribute that negative. And I'm like, here I was doing chapter 5, and now I'm doing, not chapter 5, unit 5, and now I'm doing unit 1. But that's the nature of a final exam, is that minus 2x and plus 4 equals 21. And it's just a linear equation. So I'm just combining like terms. 6x plus 4 equals 21. I've gotten so tired. It's kind of been a really long day that I probably should check my answer just because of being crazy and getting the wrong answer because I'm tired. And 17, and then I'm going to divide by 6. So x equals 17 over 6, which it doesn't bother me at all that the answer is a fraction because fractions are actually my friend. And so I'm going to plug into the original just like I see. I'm going to put 17 over 6 in my calculator and have it stored as the answer just because I have to put it in twice and I'm tired. So 8 and then answer minus and then parentheses and then 2 times answer and then minus 4. and I had stored 17 over 6 in here, and I should get 21. And I'm just going to make a mark that, hey, it was a solve and I checked, right? And I used my calculator to check. And so great. So now I have 5 more problems to do. I'm feeling more confident that I can do them than I did before. And except for I see A's and B's, and I'm like, oh my gosh, I was thinking 5 more. And with A's and B's, it's becoming more than that. Are there A's and B's here too? Oh my gosh, A's and B's here too. Okay. It's good for me. Okay, so I have absolute value 2x plus 1. This is the A. And minus 2 equals 4. And absolute value has to be all by itself on one side of the equation. So I'm going to add 2. And I get the absolute value of 2x plus 1 equals 6. And I think I've already written today the if-then. If I have the absolute value of star equals a positive number, then star equals the negative of that positive number and the other solution. There's 2 solutions. Star equals the positive number. So I'm like, okay, I'm going to find 2 solutions here for A. So I'm going to have my star is minus 2x plus 1. So minus 2x plus 1 equals negative 6, the opposite of my positive number. And then the other solution, and you put an or in between. I don't get crazy on people when people put an and in between, because I'm like, we're just first learning. But it is truly an or. And your Math 1 teacher probably will get crazy on you. They'll probably say, wait a minute, that should be. So that's why I try to do it right. And I'm dividing by negative 2. So I get x equals 7 over 2. That's one answer. Then I'm going to take away 1. And fractions are okay. Fractions are some of my best friends. And I get x equals negative 5 over 2. So I have 2 answers. And absolute value often has 2 answers. Does it always have 2 answers? No, go check out the story with 0. And I wrote the story with 0 on the board. And so I don't have 0 here on this example because that would be 3 that we would have to do. But I do have it with negative. So this is B, the absolute value of 2x plus 1 plus 18. And I'm going to take away 18 both sides. I wish I would have put it with 0 as well. And so even though I'm tired and don't want to do any more, I wish that I would have had 1 be 0 there. And there would just be one solution then that you would need to find. But when it's negative, there is no solution. So I don't know if you remember the memory verse that I put. Of course, it's not a memory verse. Equals a negative number, right? Then the then is no solution. So that's what I have here. Okay. For people that wanted to know what was the memory verse or what with the 0, I will put it on this envelope right here. It's if, and you have the absolute value of your star equals 0, then your star, this is the then, equals 0, and you solve that and you find the one solution. Okay, so that's kind of the story there. Oh, too fast, sorry. There it is. And so those are the 3 that we had with absolute value: a positive number, a negative number, and 0. And I didn't seem to have an example here with 0, but that doesn't mean that it couldn't be on our final. And so that's the reason that I did that, just to make sure you had it on your note sheet and we're ready. Now this is with absolute value and not absolute value, square root. And I did both of these today in class 2. I'm not sure if I did them at 9 o'clock. I think 9:35. I think we only did them at 8 o'clock class. So you would take away 9 both sides, because just like absolute value, square root needs to be solved for. So I get the square root. This is 3x minus 2 equals negative 2. And our memory verse is this. if you have the square root of some whatever you have underneath there, and that equals a negative number on the other side, then no solution. So this one has no solution. And then B, so obviously I had problems like this on the final exam and didn't have both of them. And then I had to put both of them because I felt like, I didn't want taking away 4 both sides here. I get the square root of 3x minus 2 equals 3. And the memory verse is on the other side here. If you have a positive number, then you square both sides. So if you have the square root of star equals a positive number, then what you do, this could be also 0, positive number or 0. Then what you do is you square both sides. And then you solve normally. So that's what I'm going to do here for mine, right? So I'm just kind of going back to this is what you do, right? These are my little memory verses here. So I'm going to square both sides. So when I square both sides, I get 3x minus 2, because when you square the square root, you just get the radicand, the part underneath, equals 9. And then I'm going to add 2, because solve normally, and it's linear. 3x equals 11, and then dividing by 3 gives us x equals 11 over 3. And it is a really good idea to check your answer on these, but it's not a must check. And to check in the original equation would be really good. Of course, there's not an answer to check here, but there's an answer to check here. And so I'll allow you to go put it in your calculator and check it. And I will say I checked it. Now, the problem is with me doing that and saying I checked it and not really checking it, then it'll be wrong. And I'll say, but I said I checked it. So you mean I made a mistake when I solved it, which is very possible. Everybody makes mistakes. But I checked it and made another mistake and said that it worked. And so that would be my problem. But it did work when I checked it. I did get 7. So I'm like, whoo-hoo. Okay. 33. One with a plus and one with a minus. How did I make those come out nice? And I don't have an answer line for the second one, so I'll make it. There it is. Okay, how did I make those come out nice? I have no idea. So here we have both of them to come out nice. And so maybe they don't come out nice. Oh my gosh, I hope they do. I hope I don't have to use the quadratic formula. Right now, I am future self, past self got so busy that one of these was on the review, and then I realized, oh, we should have a practice with a subtract. And I didn't have a practice with a subtract. And then you might be saying, yeah, you did. It was in the first part, but I didn't know I had it. So anyway, okay, so we're going to practice when you add, you multiply. So this would be log base 6, and then I multiply these together, x times x minus 5 equals 2. So this is log base 6 of x squared minus 5x. And that 5 definitely does not look good, equals 2. And that 6 even looks worse, but now it looks better. Okay, so now I'm using my log property that we've written and used several times today, and I'm writing it in exponential form. And so I have my base, my input, and my exponent. And I'm going to write it up here because I can't stand not to write it. And you're going to be like, but you've already written that 6 times today. And so this log base and your input, and I'm listening to someone I love cough a lot. I mean, the coughing it sounds so painful. I hate it. I wish that I could give him a break, at least like an hour worth of break. I'll cough for you for an hour or something like that. It'd be so lovely. Okay, so our base is 6 raised to the second equals x squared minus 5x. So this is 36 equals x to the second minus 5x. And I'm like, this is quadratic. And don't forget that logs are must checks. So I have to get 0 on one side of the equation. So I'm going to take away 36. And I'm going to pray I don't have to use the quadratic formula. I mean, pray hard, people. And 36 is 4 times 9. And so I'm feeling really happy because when you subtract those, you get 5. So this is x, is it minus 9? Minus 9 and x plus 4, I think. And so I'm getting the answers 9 and negative 4. And so I'm going to put that here. X equals 9 and x equals negative 4. You notice I don't have that on my answer line because logs are must check. And so it's a must check. And until I check it, I'm not putting it on the answer line because they have extraneous solutions, particularly when you have add and subtract. And add is even worse than subtract about having it. So here, log 6, okay, they're the same. They're tied. For math teachers out there that are saying, no, 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 no. I'm just saying what the problems in the book have. I'm putting in 9. 9 take away 5. And I get 2. Hot diggity dog. 9 worked. So 9 comes on my answer line. Is it possible that they could both work? And the answer is yes, it is possible that they could both work. Are they both going to work? And the answer is no, they're not going to both work. But is it possible that they could both work? And the answer is yes. I could make a problem where they both work. And if you go do problems in the book, I'm sure that you will find one where they both work. And when I checked negative 4, I don't know if you noticed, I checked negative 4, I put in the negative 4, and I got math error. That's extraneous, and it's because the input to the log cannot be negative, and we have a negative value. Now, we also saw a problem in our class where our answer was negative and it involved logarithms, but it didn't make the input negative. But this one does make the input negative. So it's not just because it's a negative answer, it's because it makes the input negative. Okay, now I'm going to solve the one that's subtract, which is B. So this was A. Having to solve 2 of them at a time here when I thought I was almost done. And so is this one a double as well? It's not. It's not. Okay, yay. You're like, you're as happy as I am, I'm sure. When it's a subtract, it's a divide. So this is log base 6 of x divided by x minus 5 equals 2. So using that same property, our base is 6, our exponent is 2, and we get x over x minus 5. So this is 36 equals x over x minus 5. And how you solve this is you multiply by the denominator. I only have one denominator, and it's x minus 5. So I'm going to multiply right here by x minus 5. And over here by x minus 5. I hate when I write it on the wrong side like that. It drives me crazy because I'm going to have to distribute, and I'm going to distribute like this. And so, but it wouldn't fit on that side. So I was like, oh my gosh, you know, and I was tired and I was cold and I was hungry and I didn't know what 5 times 36 was. It's 180. X minus 5's cancel out and I get x. And I'm solving away. I need to get the variable on one side and the numbers on the other. I'm thinking about subtracting 36x to the other side. So I get negative 180 equals negative 35x. I'm going to divide by negative 35. My answer is going to be a positive value. And remember, logs are must check. And so this is 180 divided by 35. I don't have to worry about putting in the negative because a negative divided by a negative is a positive. And I get x equals 36 over 7. I don't remember that answer. And I have to check it. I have it down here on my answer line. And that was a little bit cheeky. And that was being a little bit confident that it was going to work because it doesn't make the input negative. And so, but if it doesn't work, I'm going to erase that and put no solution. Okay, and I'm going to erase really thoroughly. Okay, so I'm going to have log 6, and what was my input? 36 over 7. I hope this works. I remember it working. I was on the bus, and I came up with this problem because I don't have a textbook. because I loaned my textbook to another faculty member and now have no textbook. So otherwise I could just look up problems out of the book and that would just be so lovely. Instead I was making it up out of my head. And I do get 2. Woohoo! I remember that it worked, but I didn't remember that was the answer. Okay, 34. Oh my gosh, it's factor x squared minus 9. That's a difference of squares. I'm like, hot diggity dog. That's lovely. So that's a break. I hope I put 4 of those on the test. I hope you think that it's a break too. I hope you're going, yeah. X and 3 and 3. Okay, that's not so bad. X plus 3, x minus 3. And then the other one, B, is, oh wait, we factored that today. We factored that on one of the problems. You group the first two, x squared and x plus 6. You bring down the sign, minus 9, and then this is x plus 6. They have x plus 6 in common, so you write it in the front. And you get x squared minus 9, which we just factored. I'm like, hey, we did this problem today. This problem could be changed into something else to give us more variety, because we're like, hey, this one came up again. Now this one, we had to solve it. And this one wasn't solve, it was just factor. And so I guess there was one more step. And last one, yay. And this is a pretty good review for your final. If you're wanting other things to review for your final, if you can do every problem on this, believe you me, you'll be doing great on the final. But if you're wanting more problems to practice, I would go and practice your chapter 1, chapter 2, chapter 3, chapter 4, chapter 5 test. And if you want more practice, then I would go to the labs after, not the labs, the quizzes after that. And then the labs after that. And so that's Tyler's godfather asking, how is he? Everybody's worried about Mr. Tyler with his big high fever. And okay, there's asking me to find the slope. How you find the slope is you solve for y. And so I have to take away x from both sides of the equation. I will answer him. And I guess he's not texting Tyler directly because he probably thinks that Tyler is well, he had a fever of 106 this morning. So, and so he's probably thinking that he's needing to rest, which is really nice. Okay, so the slope, put your finger on x, and that's the slope. And so if I did, it would be over 3, right? If I put my finger on x, it would be fraction bar over 3. Well, fractions don't run around without tops, so the numerator is 1, so this is 1/3. So the slope is 1/3. Now I want to find the x-intercept. The best place to find the x-intercept, you have 2 forms now of your line. You have this form, which is called slope-intercept form, and you have that slope y-intercept form, and you have that form of the line, which is called standard form. And to find the x-intercept, it's actually easier in standard form than it is in slope-intercept form. So I just found that, but I would like to find the x-intercept, and I'd like to do it as easy as possible because I'm tired and hungry and sad, and I let all the ice melt in my soda, and I shouldn't be drinking soda anyway. So, you know, too much information when we're trying to do this problem. So to find the x-intercept, I'm going to let y equals 0, and I'm going back to this form right here, which is x minus 3 times y, which is 0, equals -9. And so x equals -9. And so -9, 0. And then it asks me for the y-intercept. How you find the y-intercept is you let x equal 0. And it's just as easy this form as this form, in my opinion. And so, but actually this form is probably a wee bit easier, and we're tired, so we're going to use it. And we get the choice, right? We have the line in 2 forms. So this is over 3 plus 3. So we get y equals 3. So the ordered pair is 0, 3. Then they asked us to graph the line. And so, and I'm like, shoot, that goes right off my graph. And then when I graph a line, I want you to have 2 points on your graph. And I'm like, I have 1 point on my graph, over 0, up 3. 1, 2, 3. And that one's not too far off the graph, but you know what? I'm going to be a good person, and I'm just going to go get one more convenient point, and I'm going to pick x is 3 right here because 3 divided by 3 is nice, which is 1 plus 3 is 4. And so I'm going to plot the point 3, 4. 1, 2, 3, up 4. 1, 2, 3, 4. And then I'm going to draw it, and I'm going to see, does it look like it crosses at negative 9? And so I'll extend the x-axis a little bit here. And if this is negative 7, negative 8, negative 9, and the answer is no, it doesn't look like it crosses at negative 9. It looks like it crosses at negative 11. And so that makes me think, Donna, my dear, 1, 2, 3, 1, 2, 3, 4, over 0, up 3. 1, 2, 3. I'm going to get one more point. You're like, don't get one more point. I am going to get one more point. Oh, I'm going to make sure 3, 4 solved that one. Because it could have been when I solved it. Oh man, if that's the case, oh, that's bad, bad, bad. Minus 3 times 4 is negative 9. No, that's actually good. Yay. Okay. I'm going to pick, I don't want to pick 0 because I know I'll get 3. How about 6? So 6 is 2 plus 3 is 5. And so is 6, 5, 1, 2, 3, 4, almost. I mean, it's a little bit, it's going through just slightly under. Okay, so now, and you're like, man, are you that of a perfectionist? And the answer is no, I'm not, but I just, I want it to be perfect because it's my last problem. And if you don't care if yours is perfect, you can stop the video and I will see you. 1, 2, 3, 4. I will still love you and I'll see you on the final exam. And so let's see, 6 and 5 right there. And my ruler. Take my glasses off for better coverage through these points. And now, can I convince myself, even though you're saying it's the same line, well, it's not exactly the same line, but you can see that it went through. Can I convince myself that that's at negative 9? And the answer is, at this point, yes, I can. And so it was just a little bit a slight twist of my ruler. So even with a ruler, it can get off, but without a ruler, it gets really bad. So please, please bring this or an ID to take your test. Okay, good luck, good studying. Stop recording. See you tomorrow.